Hiya and welcome to the second video on similarity. This video is all about the scale factor being applied to the area and volume of similar shapes now. Your success criteria for this video will be able to find the linear scale factor, which we did in the last video, of either an enlargement or a reduction, being able to convert that scale factor into an area or volume scale factor, and lastly, to be able to apply that area or volume scale factor to find the area or a volume of a similar shape. Okay, so in our last video what we looked at was the linear scale factor, and if you were making an enlargement between similar shapes, then what we would do is we would do the big side divided by the smaller side, okay? And if it was a reduction, then we would be doing the length of one of the smaller sides divided by the length of one of the bigger sides. And then we would go apply that to find another length. Now what we're going to be doing is trying to change that scale factor into another area or volume scale factor now. And if you think of the linear scale factor, you're always just finding the length of a side, so it's always just a one-dimensional line, whereas now the area was now a two-dimensional measurement, so that is why we now square the scale factor that we figured out before. So for example, if you'd figured out the linear scale factor and you had the answer 2, now to turn that into an area one, all we need to do is square it. So 2 squared is 4, and that's us done. If, again, you figured out the scale factor of a linear scale factor was 2, and you wanted to turn it into a volume scale factor this time, now you're thinking about a three-dimensional object, then you need to now cube it, and that would give you the answer of 8. So that is how you go between the linear scale factor and changing it into either the area or volume one. All you do is either square or cube it. Okay, so our first example then, we've got two similar shapes, and as you can see, we've got the length of 2 here and a length of 3 on the larger one, and the unknown area that we're trying to find is in the larger shape, so it's going to be doing a scale factor of enlargement. So like before, scale factor of enlargement is equal to big divided by small, so 3 divided by 2, and we can leave it like that. Okay, now to do the second part and to convert that to the area scale factor, that's our new part. That is when we have to do, so area scale factor of enlargement, we take our scale factor from above and now we just turn it into an area one by squaring it. So to square a fraction, you just square the top and the bottom number. So 9 over 4. That's us for that. And lastly, to get this area that we're trying to figure out, we're going to use the area of the smaller one that we already had, and we're going to multiply those. So the area 2, since it's the area of the second one, you do the area of the first one, 4, and you multiply it by the scale factor. Okay, remembering to multiply by a fraction, you divide by the bottom number and times by the top. So you get a final answer, a final area of 9 meters squared. And that's you totally done that. Right, so for our second example then, we can see that we've got two similar shapes. On one side we've got the length of 8 centimetres. On the larger side we've got the length of 16 centimetres. And the shape we don't know the area for is on the smaller one. So we're going to be doing a scale factor of reduction because we're going in that direction. So scale factor of reduction, like we've done before, small divided by big. Okay, and you get 8 divided by 16, and simplify that down, you're going to be a half. Right. The new part then, changing that into an area scale factor. You take your scale factor from above and we are just squaring it. You get 1 over 4. Okay. Lastly then, to apply that to find the missing area, then all we have to do, get the missing area, is take the area they have given us from the larger one, so 88, and multiply that by the scale factor. Remembering to multiply by a fraction, you divide by the bottom and then times by the top. So 88 times 1/4 is 22 centimetres squared. And that's you. Okay, so this time we've got a volume example. So we've got two similar objects and we've got the length of 45 centimetres on the bigger one and a length of 15 centimetres on the smaller one. We know the volume of the smaller one is 0.7 litres and we're going to be trying to find the volume of the larger object. So we don't know the larger one, so we're doing an enlargement. So scale factor of enlargement, big divided by small, just as we've done tons of times before now. Okay, so the length of the big side is 45, divided by the smaller side, 15, and that gives us a scale factor of 3 for linear. Right, now converting that to volume. So this is the new part again. To get the volume scale factor of enlargement, if you remember, you just take your linear one from above, but this time it's volume 3-dimensional, so we're cubing that number. So 3 cubed, and that will give us the scale factor for volume is 27. Okay, now the third part, now apply that to find the missing volume. So to get the volume of the larger bottle, you're taking the smaller one that you were given at the start, 0.7, and timesing that by our scale factor we just calculated, 27. And if you do that, you get 18.9 litres. Okay, and that's us. Okay, so here are 3 examples that you can try do on your own now. Try for each one, get the scale factor, and then the area or volume scale factor, and then go and apply it, so kind of 3 steps to each. Okay, off you go, pause this video now. Okay, so there's your answers, and if you're stuck at any of these and you need to ask in class, then please do, or if you're looking for any more examples. And this is everything now to do with area and volume scale factor, and your next video will be on working backwards using scales and scale factors.